Hello, and welcome to another IB Math Speedrun with me, Vince. So today we're going to be starting on Chapter 4, which is all about differentiation. So yeah, let's jump right in. So today we're going to be completing Chapter 4.1, and before we get into differentiation, if you don't know what that is, don't worry, we need to talk about limits, continuity, and convergence. So what is a limit? So a limit looks something like this. It's a limit of typically a function, f of x, and it will be when x tends to some number, usually c. And what do we do with limits? So if you imagine the function 1 over x, which looks something like this, you can see that from here, as x gets closer and closer to 0, at least from the positive side, then y gets closer and closer to infinity. Like, it will approach and keep on approaching, but never actually reach infinity. And if you look at the negative side, x approaches negative 0 from the negative side, then y approaches negative infinity. So because it never actually reaches that value, we have to use limits to work with these values that the functions tend to but never actually reach, and so that's going to form a very important part of differentiation. So just quickly going over this limit again, limit of f of x as x approaches a, say, means that it's the limit as x approaches a. So if we put a plus sign next to this a, it means it approaches it from the right. And if we put a minus sign, it means it's approaching a from the left. So let's draw the graphic here. If it's a minus sign, it means it's approaching a from the left. And if it's a plus sign, it means it's approaching a from the right. If we leave this out, if you leave this symbol out, it means that the limit is the same for both directions. So for both directions in the curve or function, as they approach this value, the limit will approach the same value. So that's what a limit is. And normally, let me erase that. Normally, we used to say the limit here, which we'll label as capital L, is the same. Like, if we ignore this minus or plus sign, this is equivalent to the limit of the function as x approaches a from the plus side equals L, and the limit from of the function as x approaches it from the negative side is also equal to L. So both of these cases are equal to L, and L, of course, being a real number. That is one condition. So yeah, with that being said, let's evaluate some limits. So let's jump into the questions, and I'll be doing the even ones today. So the first question is, it's asking for the limit of x as x approaches 3 of the equation x squared minus 9 over x minus 3. So the first thing, how they want us to deal with limits first is to graph the actual function. And that's fair enough, because graphing a function can easily help us tell what a limit is. So again, I'm going to open up Desmos and graph x squared minus 9 over x minus 3. So x squared minus 9 over x minus 3. And as you can see, this looks like a fairly continuous function with one catch. If we actually zoom in very close, obviously we can't zoom in very close, but this function actually isn't defined for when x equals 3, since we can't divide by 0, right? So this would be, if x equals 3, then we're trying to divide x squared minus 9 by 0, which simply doesn't make sense. So that's why we have to use limits to evaluate the value of the function as x approaches 3. So we have to ask ourselves, what is the limit of this function when x approaches 3 from the left side, and what is the limit as f approaches 3 from the right side? And if you look at the graph, if we approach 3 from the left, we get this value over here, 6. And if we approach 3 from the right, we also get 6. So since both of these are equal to 6, then the limit of this as x approaches 3 is equal to 6. Okay. Now on to the next question. And next question is asking us to evaluate the limit of x cubed minus 1 over x minus 1 as x approaches 1. Again, we have to use a limit to evaluate this because this function has no value, or it's undefined, when x actually equals 1. So that's why we have to use limits to see what x gets to as it approaches 1. So we have x cubed minus 1 over x minus 1. And as you can see, it looks like a fairly continuous function again. So as x approaches 1, where's 1? Okay, it's over here. As x approaches 1 from the left, f of x approaches 3, and the same is for the right. So we can therefore say this is equal to 3. Okay, finally, we want to evaluate the limit of, as x approaches 0, of x minus 6 to the 2/3. Oh, sorry, x approaches 6. The limit as x approaches 6 of x minus 6 to the 2/3. So we have to plug in our function, x minus 6 to the 2/3, and it will look something like this. So as x approaches 6, well, as x approaches 6 from the left side, y approaches 0. And as x approaches 6 from the right side, y also approaches 0. So we can say this limit is equal to 0. Yeah. And that is pretty much it. So, yeah. That is all. So, I hope you enjoyed the speedrun, and I hope you're confident with working with limits now, at least from a graphical standpoint. In the future, we'll be looking at limits from an algebraic standpoint and trying to evaluate them from there. So, see you then.